So let's say g of x is equal to x plus 1 times x minus 3 over x squared minus 1. Okay? So, do we have a rational function? Sure. We have a polynomial in factored form over a polynomial in standard form. Just because I didn't know what that was in standard form, I just wrote it myself right then. And then standard form. But there's two polynomials, so it is a rational function. So the first thing that we want to do is factor anything that needs to be factored. So that would just be the denominator in this case. So x squared minus 1 would be x plus 1 times x minus 1, right? And then if we can, we're going to divide out or cancel anything that works from the denominator and the numerator, and that is then reduced. So this is called a reduced form of our rational function, just the x minus 3 over the x minus 1. However, remember, we should find the domain from both of these parts, okay? So for the domain, we are looking at x plus 1 cannot equal 0. So x cannot equal negative 1. I'm taking that from this denominator. And x minus 1 cannot equal 0. That's from this one. And that means that x cannot equal 1. Okay? Okay, so looking at the graph, okay, notice that when I typed in the equation, I did remind you, you need an extra parentheses around the top to say that both those parts are in the numerator. And then you still need a parenthesis around the denominator to say x squared minus 1 is the denominator. So put it in that way. And then you can see in the graph that you do indeed have that vertical asymptote at x is equal to positive 1, right? And then you have, you can't see it in the graph, but you can see in the table that at negative 1, you also have a hole, a removable discontinuity. Okay, so let's graph that on our paper. And write that down. So this vertical asymptote, woo, oh my, was like my worst vertical asymptote ever. And notice that you do want to graph these using your calculator because this one did end up looking a little different than the original, right? It looks like this. It has a little bit of a reflection to it. And then at negative 1, you want to draw a circle there for the removable discontinuity. So we have the removable discontinuity or hole at negative 1, x is equal to negative 1. And then if you're wondering, well, then what is that point? What is the y value? Then you just plug it into the x into the simplified version. You can't really plug it into the original or you'll get 0 over 0. But if you plug this into, to find the y, plug it into the simplified version. So plug it into x minus 3 divided by x minus 1. So that's negative 1 minus 3 over negative 1 minus 1. That's the x coordinate plugged in. I'm getting negative 4 divided by negative 2. So I'm getting 2. So on my point, that is my hole, is the point negative 1 comma 2. That's right there. Negative 1 comma positive 2. And then here my vertical asymptote is the vertical line x is equal to 1. So I'm going to be asked about like where is the vertical asymptote specifically? It's at x is equal to 1.